Assalamu alaikum students. Article for today is basically polarization, and as the name indicates, any system which is definitely having poles, that is if we're talking about the charges or atoms, then definitely it would be like positive charges on one side and negative charges on the other side. So this is basically polarization. To understand the phenomena, we have taken two charge plates and connected them with the help of some battery source, and positive charge q on one plate and negative charge q on another plate. And in this case, electric field established from the positive plate to the negative plate, whose value is suppose 5 newton per coulomb. And in the second case, we have placed a dielectric between that particular charge plates, but we haven't connected this particular circuit, right? And in this case, you can see atoms of the dielectric are randomly oriented, and the dielectric which we have placed it, why we place it, because it increases the capacitance, right? So that's why it is more helpful for us, and it increases capacitance while it decreases electric field intensity, right? So electric field intensity, how it would decrease, so before that we connect this particular circuit, and in the center you can see dipoles have been created. All the positive charges are aligned towards the negative plate, and all negative charges are aligned towards the positive plate. And in this case, we see that inside that particular dielectric, an electric field has been established, represented by ED, and its direction is completely opposite to the external field. In this case, the value comes out to be of the external field comes out to be 2 newton per coulomb, which was earlier 5 newton per coulomb. So why this external field has decreased? To understand this phenomena, what we do, we we seek to determine ED, and value can be determined by subtracting the earlier value, that was 5, with the E prime, which is 2, and we get answer 3 newton per coulomb. That means the value of ED is 3 newton per coulomb in the opposite direction of the electric field. That's why the electric always decreases E. Dielectric is of two types, polar and non-polar, and polar molecules or polar substances, as the name indicates, these substances or these molecules should be such kind of substances, those which must be having a permanent dipole, right? And what is meant by permanent dipole? Permanent dipole definitely means that this dipole has been created all the time, right? And what about the non-polar substances or the non-polar molecules? How can we explain them? Basically, the non-polar molecules, they do not have poles in the normal conditions, right? When the electric field is absent, and they become polarized, the non-polar molecules, they become polarized in the presence of electric field, right? So as the electric field is provided, external field is provided, they will definitely align themselves in the dipoles. And the polar molecules, they are always in the dipole, in occurring in the dipole condition, they are always polarized even in the absence of the electric field. So this is the basic difference between the polar and non-polar substances or the molecules. And examples can be for the non-polar molecules, example could be of oil, and oil can be understood as a non-polar molecule. And for the polar one, we have sodium chloride, in which chloride is basically a negative ion and the sodium is basically the positive ion. So dipoles have been created in this particular way. Now, to better understand the phenomena of polarization and the polar and the non-polar substances, we see that in the absence of electric field, non-polar substances, they behave like a normal atom, right? And electrons are revolving in the shell, and the protons are present in the nucleus, so all of the having a same center, right? And in the presence of electric field, what would happen, all the electrons will shift towards one side and pushing the nucleus to the other side, right? But in the polar substances, and in this way they've created a dipole. And in the polar substances, what would happen? They are always in dipole condition, and there is a distance between their positive and the negative charges, which is basically d, and this is known as displacement vector, right? So this is basically a dipole basically a any system in which positive and negative charges are displaced from each other by a distance d. Now, what is dipole moment? Dipole moment is basically the product between the charge and the displacement vector. Now, what is basically this displacement vector I'm talking about? Consider there is a dipole and the positive charges are on one side and the negative charges are on the other side, and having a distance d between them, right? So in this particular case, this displacement vector d is basically responsible to give direction to p as well, right? To the dipole moment is represented by p. So its magnitude is given by p equals to qd, and this is basically electric dipole moment, and its vectorial form p equals to q dot d. This is basically a dot product and gives a vector quantity, which is basically electric dipole moment, right? And this electric dipole moment is having a unit of coulomb into meter, right? And its direction, talking about the direction of dipole moment is always along the external electric field supplied. Why? Because all of the dipoles will try to align themselves along the external electric field, although we see that inside the dielectric this direction is completely opposite to the external electric field, but overall the dipole moment's direction is towards the electric field, since all the dipoles try to align themselves, right? And to understand this phenomena, we can draw again the same thing, two charge plates and connected to a particular battery source, and inside them the dielectric have been arranged into dipoles, positive and negative charges. And in this case we see that external electric field is towards the right side, while inside the dielectric the field is from the positive to the negative charges, that is towards the left side. But overall the dipoles which were created because of that external electric field, they will trend to align themselves along with the external electric field. So we say that the direction of dipole moment is always from the negative to the positive, right? So this is the basic convention we use in physics, and the dipole moment's direction is from negative to the positive one. Thank you so much.